Hello students, today we are going to learn about VLSI lab. So in VLSI lab, you are going to study about the both analog part and the digital part. So for your summer semester, you have a syllabus with the analog and digital part. So we'll study one by one. In a digital part, you are going to write a Verilog code for the following circuits and their test bench for verification, and observing the waveform, synthesizing the code for the different types of the circuits that what we have studied in the previous semesters, like inverter, buffer, transmission gate, basic and universal gates, flip-flops, serial and parallel adders, synchronous and asynchronous counter. And at the end of each sessions, we are going to will be learning about some of the multiple choice questions. In session 1, the experiment 1 about the before studying the experiment 1, will follow the some of the steps how to execute the programs in Xilinx platform, that is synthesize and simulation. Synthesize, the definition for the synthesize is whatever the program we are writing, for that it will give an equivalent gate level module. Okay, so in synthesize, we need to select the Xilinx tool, that is go to start menu, all programs, Xilinx ISC 12.1, select the project navigator, go to the file menu, close any previously opened project if any, enter the project name and location and select the top level module. Next, in step 4, select the product category as a general purpose device, device name as some what type of device we are selecting, that is also important, and for FPGAs. Right click on the source file and select the new source, speed followed by the Verilog module, and give the file name as the name of the entity. Next, define the ports used and their respective direction in the next. Write the both Verilog code and test bench code in the workspace that opens and save the file after the completion of editing. Go to the process view window and right click on the synthesize XST and then click on the check syntax. Check syntax where you are checking if any errors are there. Next, correct if errors. Steps for the simulation. Write the Verilog test bench program. Make the alteration in the clock information initial length of the test bench. Initially, both of your Verilog programs have to be compiled. After compilation, you have to elaborate the top level model. Go to process view under the Xilinx simulator. Right click on the simulate behavior model. So all these steps you will be following once you work on the Xilinx tool platform. Next, these are the theory concept, that is hardware descriptive language is describing digital design. It is one of the hardware description language and it is similar to C language. Earlier days we will be using a schematic capture to draw any of the logical circuit. From the library we are taking the some of the capture devices, okay, readily available in the design library. But here in hardware descriptive language we are writing the program for the particular design, that is bit easier and similar to your C programming. And it is invented in the year of 1984. Tremendous productivity implemented for circuit designers who were already using the graphical schematic capture software and specially written software programs to document and simulate the electronic circuit. Designer of Verilog wanted a language with a syntax similar to C programming language, which was already widely used in the engineering software development. A Verilog is a case sensitive, has a basic preprocessors and equivalent control flow. Introduction to Xilinx. So here for execution we are using the tool, name it as a Xilinx ISC. Xilinx is a integrated synthesis environment, is a software tool produced by Xilinx. Synthesis and analysis of HDL designs, enabling the developer to synthesize their designs. Performing timing analysis, RTL, that is register transfer levelity, will give an equivalent gate level design. Stimuli and configure the target device with the programmer. ISC is the project navigator, which includes the design hierarchy, editor, an output console, and a process tree. So these are the introduction about the Xilinx tool. So after that we have, in this session we are learning the first experiment in a digital design, that is an inverter. So the aim of the experiment is we need to write a Verilog code for an inverter and its test bench for verification. So the tools required is Xilinx 12.1 ISC, and have already aware, we have learned in third semester, we are studying till the previous semester is also NOT gate. NOT gate is also one of the important logical device where it gives a complemented output. Okay, it is also known as inverter, and if the input variable is A, then the output variable is also not of A. This is the symbol of the NOT gate, and these are the two way of converting the universal gate to the NOT gate. This is the program what we need to write, the Verilog program and the test bench program. In Verilog program starts with the module name, anything similar to you can give, but it should not be in our keyword or anything. Okay, parameter, that is input and output. Assign, this is a concurrent statement, that is B is assigned to not of A in module. Next we have a test bench program where we are giving a set of uh, inputs to execute or to check the main program, that is called as test bench. Earlier we will be giving inputs through the waveform, but here in test bench it's in the form of program where you can give n number of inputs. So this is the waveform what we'll get after the execution, that is when input is 0, the output is high. When input is high, the output is 0. So these are some of the multiple choice questions, that is the VLSI technology uses dash, that is transistor to form a IC, which is the high level representation of VLSI design. Problem statement, which among the following is the process of transforming design into information, the circuit to a set of equation? Synthesis. Dash is the fundamental architecture block or element of target PLD logic cell. The inverter output is complemented. So like this we'll get some of the multiple choice questions or a viva questions they may ask in a lab. Okay, so before going to the next session, we'll learn how to execute the program. This is so in main desktop window we have a tool called Xilinx Design ISC suite. So just double click on this. Once you double click on it, it will give a tip of the day. Just you press OK here. Next, if previously open any files are there, just close that. Next, file, new project. Here you need to give the name of the project, that is what you are writing. Inverter. So previously given any name is there, just don't repeat that, change, give the other names. Here the location, working directory and top level sources HDL. Let's go to next. Here it will give the what type of synthesis tool and simulator what it has used. Okay, and here the family device what it has selected. Go to next, finish. Okay, after that go to next step is project, new source. Here you are writing the Verilog module for the inverter. So give the name in INV, the different name. Yeah, project name is different, and here the Verilog module name, it will come with your module what you are writing. So for that inverter 9. Okay, next. Here you need to define your input port and output port. It will be a set of input port, or else directly also you can write it in a program. Okay, here you will be defining the input because for inverter you have a single input and single output, and here it is output. Select it as a out. Okay, next, finish. So here you'll get a module name. Once you define the parameter input and output parameter, just you need to give the concurrent statement. Assign B is equal to shift A. So this is my concurrent statement. So to show some of the errors, I'll remove this semicolon. It will give a error. So once you edit the program, just do the save, Control S. So it will give a error, syntax error. So before the line of the end model, we have a syntax error. So that is, we need to put a semicolon for that. Just put a semicolon, and once again do the save, Control S, and here we have a left side, we will be writing a program what we have written, that will be stored. And in this process we have this design utilities, user constraints, implement design. Just select synthesize XST, check syntax. So once your program is proper, no errors are there, means it will give a green tick, that is check syntax is over. Next, right click on the program what we have written, new source, select the Verilog test fixture INV 9 shift underscore TB. It is important, you need to give a underscore TB for the test fixture or test bin program. Next, finish. So directly you can edit from the starting the Verilog program, or else you can give the values here. So already 0 is there, just you give some of the alternate values for the. Okay, we'll run this, we'll give the delay for 50 nanosecond. So this is the delay what we are giving. Okay, once this values we have given, input values, just once again you save it, Control S, and here we have one implementation and simulation. Implementation, in that check syntax is over. Now select the simulation. So once you select the simulation, it will give a design utilities. Under that we have this okay, here click on this. So ISC simulator, simulate behavioral model. So run for some delay 10 nanosecond and zoom on this. Okay, here once you press this zoom icon, zoom to full view. So whatever the delay again with respect to that, it will give an output, that is 0 1 0 1. Okay. Next, in ISC, so you can view your implementation design. You can view the RTL schematic also, that is equivalent gate level design. So select this, start with the schematic top level block. Okay, here double click. So this is the inverter symbol. For that what we have selected, it will give input and output. So the internal diagram of the inverter. So this is how we can write the program, see the waveform and RTL schematic. Okay students, thank you. We'll meet in the next session. Okay.